In last week's video, we saw how a magnet will repel and attract a coin depending on how you move it. I asked the question, why does this seem paradoxical? Like, if you move a magnet across a coin, it repels it. But if you move a magnet and lift it above the coin really fast, it attracts it. In order to really understand what's going on, we have to kind of look at this visually. So let's take a look at these diagrams. In the first diagram, we can see how when you slide a magnet on top of a coin, the top of the coin becomes the same polarization as the bottom of the magnet. So as the magnet moves over it, it pushes away at the coin. This effect is seen more prominently when you're not moving the magnet too fast or too slow. There is a pretty good in-between space where it happens very well. So let's take a look at the second diagram, where you're lifting the coin into the air with the magnet. But let's take a look at the video again and see what's going on in slow motion, and then we'll take a look at the diagram to kind of break things down step by step. As you can see, when I start to lift the magnet into the air, the coin comes up with it and begins flipping over. Sometimes it flips all the way over, sometimes it makes it about halfway, but the point is the coin wants to flip over. And therein lies the answer to the question. You see, when I start to lift the magnet into the air, the top of the coin and the bottom of the magnet are the same side, the same polarization, so they're repelling each other. But because the coin is so thin, the south side of the coin's electric field is attracted upwards towards the bottom of the magnet's north field. This is an effect that you've seen when you take two magnets and repel them and then let one go in midair, and it flips over really fast. And the reason this happens is because the magnet is actually unstable on one of its axes, so you can never truly make a magnet levitate above another magnet in free space without stabilizing one of the magnets from flipping over. So as the magnet is being lifted into the air, the coin is flipping over to try to magnetize up toward the magnet, but then it gets too far away, or I stop moving the magnet and the electric field of the coin completely disappears. As we saw in the first video, American coins aren't magnetic, but because they're conductors, they're mostly made of zinc and copper and nickel. You can move a magnet over them and it will always repel them. This is an effect known as Lenz's law, in which a moving magnetic field will always create an opposing electric field above a conductor. That's also why if you drop a magnet down a copper tube, the magnet will drop very, very slowly, because the electric field being generated as it travels through the tube is repelling upwards against gravity. What are some other cool experiments I should do with magnets? Leave your ideas and suggestions in the comments below, and I will make sure that I take a look at them and put something together. And if you enjoyed this video, don't forget to like it and subscribe it, and maybe give it a share with all your friends. And don't forget to take a look at my Patreon page, and over on my Instagram page, you will find a bunch of slow motion science videos where I post a new post every single day. And if you haven't seen my books yet, this is the second one in the series that I have right now. There are 3 out. Every time you purchase one of these books, 50% of the profits are donated to STEM and environmental conservation programs, with a particular focus on saving sharks and ending shark finning. I donate money quarterly, so I've been doing this for a little bit over a year and a quarter actually. So make sure you check them out, and if you purchase one, know that that's where your money's going. Don't forget, as I work for a more sustainable future, all of my videos are produced using 100% solar energy. So go give these magnet experiments a try for yourself, and in the meantime, I will see you next week. And as always, here's to all your endeavors.